Hello students, welcome to my YouTube channel.
Measures of variability and dispersion, we are going to see the first variance, standard deviation, standard error, and range. Let's see this in detail. Variance. The variance measures the average square deviation of each data point from the mean. The variance is denoted by a symbol sigma square. So how to calculate the variance for ungrouped data? So for calculation of the variance for ungrouped data, the formula used is here. So sigma square is equals to 1 by n summation of xi minus x bar bracket square, where the xi is the data point, x bar is the mean of the data, and n is the number of data points here. So example of the variance for the ungrouped data is given x equal to 2, 4, 6, 8, 10. For this given data set, the variance is calculated by using this given formula. So in this formula, the values of the xi are 2, x1 equal to, first we take x1 equal to 2, x2 equal to 4, so on we will get the value of the x5 equal to 10. Calculate the mean of this data. So then find out the value of the xi minus x bar. So once you get the values of the xi minus x bar, so then find out the summation of the, find out the square of the xi minus x bar, and then take the summation of the this here. So you have to make the such columns and find out the values of the xi minus x bar bracket square. Once you get these values, so divide it by the total number of data points. So you will get the variance 8. So all of you have to complete this in a tabular form. The next one is the grouped data. The variance of the grouped data is determined by using this formula. Sigma square is equals to 1 by n summation of I equal to 1 to n fi dot in bracket xi minus x bar bracket square. So where the fi is the frequency of the class, xi is the midpoint of the class, x bar is the mean of the data, n is the total number of observations. So here we are calculating the total number of observations by using the formula that we have seen already. N equal to summation of I equal to 1 to n fi. So total number of frequencies. So that we are determining. So that is nothing but the total number of observations and the value of the this capital N. So fi is the frequency of the that individual class. So xi. So xi is the midpoint of the class. Let's we see this with the help of the example. Here in this example, the class interval is given 0 to 10. Frequency is 2 for this class interval. Second class is the 10 to 20. The frequency is 3. So for all these classes, you have to find out the midpoint. So as we have seen the formula for finding the midpoint of the class, there the lower limit of the class plus upper limit of the class divided by 2. So from this we find out the midpoint of the this class. So 0 plus 10 divided by 2, we get the midpoint 5. For the second class, 10 plus 20, 30 divided by 2, 15. So likewise, you have to find out the midpoint of the other classes. And here we have determined the midpoints of the classes. So this is the xi value. Remember this. So after finding the midpoint, you have to find out the mean of the data. The mean of the data is determined as, so mu is equals to, so we have to use the frequency formula, that is the formula that is used for the grouped data. So in this we are using the frequency Fi into Xi, where I equal to 1 to n, so divided by total number of frequencies. So from this we get the mean of the this data. Once you get the mean of the data, so use this formula and determine the variance of the grouped data. So all of you have to complete this task. So here you add the column and find out the values of the xi minus x bar. Here you determine the value of the xi minus x bar. So then after you have to make the one more column in which you can find out the value of the xi minus x bar bracket square, and later on here you have to take the summation of the all this, so that you will get the summation of the fi minus x bar. So again before this you have to multiply it. Again one more thing is there, you have to multiply, you have to add the one more column there, and in that the column head should be the fi into xi minus x bar bracket square. So this columns you have to make, you have to add this columns here. So first, second, third. So this will be your first, fourth column. So this will be the fifth column, and this will be the sixth column in your table. And find out the summation of the all these, and you will get this value summation of the fi into xi minus x bar bracket square, and divide it by the total number of frequencies, so that you will get the value of the variance. As here we have determined the value of the variance, so you just cross check the your answer. The next point is this standard deviation. So standard deviation is the square root of variance, which gives the average deviation from the mean in the same unit as the data. So standard deviation is denoted by the symbol sigma. So for the ungrouped data, the standard deviation is taken. So in general, we say the standard deviation or sigma equal to the square root of the variance. Square root of the variance you have to take. So you will get the standard deviation. So for the ungrouped data, the standard deviation equal to square root of 1 by n summation of I equal to 1 to n xi minus x bar bracket square. So first you have to find out the variance, and you take the square root of the variance, you will get the standard deviation. So standard, as we know, the variance for continuing the previous example, as we have calculated the variance 8. So just you have to take the square root of this variance. So you will get the standard deviation. So for the grouped data, so same formula is used here. So you have to use the same formula as we have used in calculation of the variance, and take the square root of that. So we got the variance in last example 142.52. You take the square root of that, you will get the standard deviation. So next one is the standard error. So standard error of the mean estimates the variability of the sample mean if multiple samples were drawn from the population. So standard error for the ungrouped data is calculated as standard error is equals to standard deviation divided by under root n. So by using this formula, you can find out the standard error. So for determination of the standard error, first you have to find out the standard deviation, and then you can find out the standard error. So where the sigma indicates sigma is the standard deviation, and n is the total number of observations. So here you take the you can calculate the standard error. So as we got the standard deviation 2.83, and the n is equals to 5. So you take the square root of that n and find out the standard error. So next one is the grouped data. So standard error for the grouped data is determined by using this simple formula. So only the change is the calculation of the total number of observations. So that is the you have to find out the total frequencies. So that is determined by using the this formula. That is the summation of I to n equal to I equal to 1 to n. So fi. So from this you can find out the total frequencies. So this is very simple. Once you find out the variance, you can easily determine the standard deviation and standard error. Here we got the standard error for the previous given data 3.08. So next one is the range. Range measures the difference between the largest and smallest data points. So for the ungrouped data, so let's we see the range is equals to as is the difference between the maximum value of the data point minus minimum value of the data point. So let's we see the example of this for a given data. So 2, 4, 6, 8, 10. So what is the maximum value? 10. So what is the minimum value? 2. So you take the difference of the maximum value minus minimum value in the given data set. So that is nothing but the range. So calculation of the range for the grouped data, the same formula is used, but here we are taking the limits as the data is given in the class intervals. So that's why we have to take the lower limit and upper limit of the class. So where the Umax is the upper boundary of the highest class. As we have seen, the various classes are given there. So in this example also you can see. So 0 to 10, this is the first, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Here you have to identify the highest class and lowest class. So the lowest class is the 0 to 10 and highest class is the 40 to 50. So now you have to take the lower bound of the lowest class and upper bound of the highest class. So this is important for calculating the range. So again, I'm repeating here. First, you have to identify the which one is the highest class and which one is the lowest class. So you have to take the lower bound of the lowest class and upper bound of the highest class, and then only by subtracting the upper bound of the highest class, so subtracting the taking the difference of the upper bound of the highest class and lower bound of the lowest class. So that is the upper bound of the highest class minus lower bound of the lowest class is nothing but the range. So but again I'm repeating here all of you. So remember that first you have to locate the upper class and that you have, first you have to locate the lowest class and highest class, then only you can find out the upper boundary and lower boundary for the that particular class. So upper boundary of the highest class and lower boundary of the lowest class. So these are important for finding the range of a grouped data. So here the lowest class is the 0 to 10 and highest class is the 40 to 50. So lower bound of the lowest class is 0 here, and the upper boundary of the highest class is 50. So here we have taken the highest class, high upper boundary, lowest class, lower boundary. So that is a 50 minus 0 equal to 50. So this is the range of the given grouped data. So the next point is the moment. So when we talk about the moment in context with the math and physics, the moment describes the how quantities are distributed related to the reference point. So this moment can be calculated about the origin, mean, or any arbitrary point. So moment describes the shape and characteristics of the data around mean, origin and any point. So when we calculate the moment, so we find out the first moment, second moment, third moment and fourth moment here. So whatever the our syllabus is designed, so in according to this syllabus and looking to the previous year question papers, so the moment up to the fourth will be asked in the examination. That the first moment, second moment, third moment, and first moment. The questions will be asked only calculation of the first, second, third, and fourth moment. So let's see the moment about the origin. So this is the formula that is used for calculation of the moment about the origin. So the notations or the symbols that are used for the moment about the origin, mu dash. Okay, so r is the rth moment here. That is the first, second, third, and fourth. So this is the meaning of the r. So here in our examples, the r will vary from 1, 2, 3, and 4. So we are going to consider first, second, third, and fourth moment. So this is the formula used for finding the moment about the origin. So mu dash r equal to e of x minus 0 r. This is the rth moment, where the e of x is nothing but the expected value of the x. So here expected value of the x, that is the first moment about the origin. How we read this? The first moment about the origin is the mean here. How we calculate the mean? So that is the mu is equals to, we know, summation of I equal to 1 to n xi, so total divided by n. So by using this formula, particularly this for the ungrouped data, so we find out the mean. So same, that is the expected value of the x, that is the first moment is the mean. So this is the second moment, third moment, and fourth moment. So later on we are going to see this in detail for the grouped and ungrouped data. So this is a moment about the mean. So mu r equal to e of x minus x bar to the power r. So r indicate the rth moment here. That is the first, second, third, and fourth moment. So moment about the mean, first moment about the mean equal to 0. How we get the first moment about the mean equal to 0? So when we expand this, e of x minus x bar. Just I'm talking about the first moment. So what is the e of x? Just we have seen e of x nothing but the mean. So that is a, we write here x bar, mean is the x bar minus x bar. So we get the 0 here. So first moment about the mean is 0. Here we write, when here r equal to 1, we are saying first moment about the mean equal to 0. Then second moment about the mean is the variance, you remember. So third moment is calculated by using this formula, and fourth moment is calculated as. So here the expansion of this moment is given. So once you know the moment about the origin, then you can find out the moment about the mean by using this formula. So here we have expanded this, and then we have substituted the values from the moment about the origin, and we get this value. So this is the relation between the moment about the origin and moment about the mean for the first, second, third, and fourth moment. Particularly for the first, so this is the 0. For the second, it is the variance, and for the third, so this is the relation between the moment about the origin and moment about the mean. So moment about the point, it is very simple. Instead of taking the mean value, you have to take the given arbitrary point. So whatever the given point is there, so about that point you have to find out the moment instead of taking the mean value. And what is the procedure we have followed in the moment about the mean, the same that can be used for the expansion of the these values here. So let's see the moment of the ungrouped data. So moment about the origin, as I have said you, the first moment about the origin is nothing but the mean. So this formula is used for that, 1 by n summation of I equal to 1 to n xi. So this is the mean. So this is the second moment about the origin, third moment about the origin, and fourth moment about the origin. So moment about the mean. So first moment about the mean that we have seen. So this will be the 0. Second moment about the mean is the variance. So that is a sigma square. So find out the third moment, fourth moment. Later on we are going to see the numericals, and in that we will see how to find out this first, second, third and fourth moment for the grouped and ungrouped data. Right now just I am explaining these formulas. And moment about the point. So instead of taking this mean value, just you have to take the point about which you have to find out the moment. So there is the point A. Moment for the grouped data. Moment about the origin. So as the data is grouped data, so the frequencies are given. So that's why we have to use this frequency f, and we can find out the moment about the origin here. So this is the little change in the formula where the n indicates the total number of frequencies, and fi is the frequency of the that class, and xi is the midpoint of the class. Xi is the midpoint of the class and Fi is the frequency of that class. And by using all these formulas, we can find out the first moment, second moment, third moment, and fourth moment about the origin. So similarly, we can find out the moment about the mean and moment about the any arbitrary point. Here I have already explained the capital N is nothing but the total frequencies and Xi is the midpoint of the class.
Thank you for your attention.